Good day, students! Welcome back to my channel. Today marks the last week of the first quarter of this school year, at least for grade 10 science. We have already learned a lot in the previous weeks, from the lithosphere, its types and characteristics, primary and secondary plates, seismic waves, types of plate boundaries, and more. I hope you can still remember these lessons that we had. As what I have mentioned last week, this week is the continuation of our lesson about continental drift theory and seafloor spreading theory. This time, the most essential learning competency would be to enumerate the lines of evidence that support plate movement. Specifically, we want to enumerate evidences of Wegener's continental drift theory, to trace the existence of fossils of plants and animals as evidences found in the present continents that supports plate movement, explain how magnetic stripping on the seafloor provides evidence for seafloor spreading, and explain plate tectonics theory as unifying theory. So as you can see, this time we will be going back to plate tectonics theory, which we have discussed already in the first few weeks of this quarter, because we will be trying to relate the two theories, the continental drift theory and the seafloor spreading theory, to the plate tectonics theory. So let's have a short recap of the continental drift theory. Again, the continental drift theory was proposed by Alfred Wegener, and according to this theory, the continents that we have today were joined together in one landmass called Pangaea. Eventually, Pangaea split into two, Laurasia and Gondwanaland. Laurasia is the northern part of Pangaea, and now it consists of North America, Asia, and Europe, while Gondwanaland is the southern part, which includes India, Africa, Antarctica, Australia, and South America. Also, last week, we discussed that if Pangaea is the supercontinent that existed around 245 million years ago, which is around the late Paleozoic to the early Mesozoic era, there was also a huge ocean or a huge sea called Panthalassa. Now, let's go on to the evidences that support continental drift theory. In your module, there are only 3 evidences that were mentioned, namely evidence from rocks, evidence from climate, and evidence from fossils. In this video, I will be introducing 4 evidences because there is one evidence that was not really explained in the module, but it is the easiest evidence that was used by Alfred Wegener as a basis in formulating the continental drift theory. Now, what are these 4 evidences? For the first evidence, we have the apparent fit of the continents. So according to this evidence, continents look like puzzle pieces, just like a jigsaw puzzle. You will already know that one piece is connected to another piece by just looking at the features. For example, we have South America and Africa, which we have shown in the previous slide. The coastlines of South America and Africa look like puzzle outlines, so they seem to perfectly fit each other. Also, another example would be India, Madagascar, and Africa. So this small piece here in between India and Africa is Madagascar. So if you try to look at them, they seem to be perfect puzzle fit with each other. So next, the second evidence would be fossil correlation. So this evidence is the one being tackled in activity number 1 in your module. As you can see in the picture on the right, we have here a drawing showing South America, Africa, India, Antarctica, and Australia close to each other. And we also have color bands which show the places where the fossils of different animals and plants were seen. So for example, this yellow-orange band is the fossil of Cyronoptera, which was seen in South America and Africa. The brown band would be the fossil of Lystosaurus, which was found in these 3 places: Africa, India, Antarctica. The blue band would be the fossil remains, or the places where the fossil remains of a Mesosaurus were seen. And then the green band would be the larger band, which shows the fossil distribution of the plant Glossopteris. You may ask me, Ma'am, isn't it that fossils or fossil remains are meant to be found in different places? The answer is yes. However, the question now is, why are they in different places? If the continental drift theory is wrong, then the current arrangement of the continents would most probably be the arrangement of the continents millions of years ago. Ibig sabihin, kung mali si continental drift theory, hindi gumalaw ang mga continents. Pero ang tanong, bakit ngayon nagkaroon ng mga fossils sa mga lugar na magkakalayo kung hindi nga totoo si continental drift theory? Ma'am, baka lumipad, or ma'am, baka lumangoy. If we will try to look at the characteristics of each type of organisms, then we will understand why. So, for example, let's start with this. This is the Mesosaurus. The Mesosaurus is a freshwater reptile and looks like a crocodile. So from that description alone, it's a freshwater reptile. When you say freshwater, it only lives in water that is not salty. So that means it cannot pass through big oceans. For example, in between South America and Africa is the Atlantic Ocean. It means that if the Mesosaurus is freshwater, it cannot travel from Africa to South America by just swimming. Okay, it is also impossible for it to fly because it has no wings. So how come it can be found in South America and South Africa? It was only possible because maybe South Africa and South America were once connected, and this Mesosaurus was able to walk from South America to South Africa or vice versa. And then after some time, nung namatay na sila, naging fossil na sila in both places. And tsaka naghiwalay si Africa and si South America. Same thing with a Cyronoptera. So a Cyronoptera is a land-dominant species, so it means that it cannot swim from one continent to another. Assuming that continental drift theory isn't true, then the Cyronoptera must be able to swim from Africa to South America. But that is not possible because it is again a land-dominant species. Now, as for the case of Glossopteris, it is a woody seed-bearing tree, which is a very tall tree, and according to studies from its fossils, the seed would be very large and bulky. So it's nearly impossible for these seeds to be carried away by water or to be carried away by birds from one continent to another. So as you can see, this fossil was found in a lot of southern continents. The only way for this Glossopteris to be propagated in different continents is that these continents must be joined together millions of years ago such that it would be easier for the Glossopteris to propagate. For the third evidence, we have rock and mountain correlation. So what does rock and mountain correlation mean? Here in the map on the right, we have seen the mountain ranges found on the western and eastern coasts of these continents. So it simply means that rocks in different continents appear to have the same age and type. What are the odds that one mountain from one continent would have the same age and type as another mountain or another rock formation in another continent? What if these continents are almost facing each other? For example, we have the Appalachian Mountains and the Scottish Highlands in the North America. Okay, this one. And the Karoo system in South Africa and Santa Catarina system in Brazil. So these rocks, according to studies, have the same age and type. So how does this relate to continental drift? Possible that these formations or these mountains were once part of a very huge mountain that when the continents split apart, the mountain was also split apart. Thus, one part of the mountain would be with the other continent and the rest would be in the other continent. So technically, they are part of the same mountain, so they will have the same age and the same type. Finally, we have paleoclimate data. When we say paleoclimate data, it translates to past climate data. So why are we dealing with past climate data? So if we will look at this arrangement of the continents, the middle part of this map would be near the equator, so therefore it should have a tropical climate. It should receive more sunlight. Whereas as you go farther to the top and farther to the bottom, it should be colder and they should have snow. So you will be expecting that these tips of the continents South America and Africa and the southern tip of North America and Europe and Asia should have fossils that are related to having a higher temperature, and the fossils or the marks found in these areas should have relation to these areas being cold. However, that is not the case. What happened? It was found that glacial striations are found in tropical areas and coal is found in Antarctica. So, dun muna tayo sa glacial striations. What are glacial striations? So, glacial striations are marks that are left by glaciers when they are moving. Syempre, glaciers from time to time, they will tend to move from one place to another, maybe because of melting or because of environmental reasons. And when they move and they touch stones, they tend to leave striations or scratches. So, just like what you can see in this picture. However, most of these glacial striations are found in tropical areas. So what does this mean? It means that the current location of these areas with glacial striations might be in a different location millions of years ago. Dahil meron silang glacial striations, possible that they have glaciers, and these glaciers will only form in areas that are nearer the poles. So, ibig sabihin, continents with glacial striations are located either farther down or farther up the Earth. Next, coal is found in Antarctica. As we all know, Antarctica is a very cold place because it is located near the South Pole. However, what is coal? Okay, coal is not charcoal that we use in cooking our food. Okay, so coal is a fossil fuel. And when we say fossil fuel, coal is made up of dead plant matter. Okay, again, dead plant matter. So without plants, there would be no coal, which brings us to the idea that millions of years ago, there are plants in Antarctica. However, the present climate of Antarctica cannot support plant life because it is very cold there. So basically, this coal came from plants, and these plants once lived in Antarctica because Antarctica was not in the place that it is now. It was located millions of years ago in a place or in a position that supports plant life. Probably nearer the equator, but not really down below near the South Pole. Otherwise, it will not have plants and it will not have coal. Okay, so that's all for continental drift theory evidences. So again, what are the 4 evidences? First, we have the apparent fit of the continents. Second, we have fossil correlation. Third, we have rock and mountain correlation. And lastly, we have paleoclimate data. So next, we will be discussing the evidences for seafloor spreading theory. The first evidence for seafloor spreading theory is magnetic patterns. Diba? Last time, we discussed seafloor spreading theory and we learned that the seafloor is indeed moving in opposite directions. So once this molten material or magma comes out of the mid-ocean ridge via ridge push, this seafloor would move towards this direction to the left, and this seafloor would move to the right until it reaches the subduction zone. However, how did scientists learn that the seafloor is indeed moving? They looked at magnetic patterns. So what do you mean by magnetic patterns? Okay, when we go back to the concept of the different layers of the earth, we know that the magma is coming out from the mantle because of the heat that is coming from the earth's core. And the interior of the earth is mostly made up of minerals. And most of these minerals are magnetic. Okay, these minerals or these elements would be iron and nickel. So whenever the molten material goes up, it has with it iron and nickel. And according to studies, these iron and nickel found in the lithosphere would realign themselves according to the magnetic polarity of the earth. Okay, so I hope you can still remember what is a magnetic polarity or what is magnetism, because it was discussed when you were in grade 8. So again, going back to the seafloor spreading, the lithosphere or the iron and nickel particles in the lithosphere would tend to realign based on the polarity of the earth. And according to scientists, magnetic reversals would occur around 100,000 years to a million years. It depends. But then these are recorded in the lithosphere, just like in this picture. Okay, so you can see orange and gray here. So this pertains to reversals. Okay, let's have a better look of reversals as shown in the lithosphere. So as we can see here, the normal magnetic polarities are shown by the colored strips, whereas the reverse polarity would be shown by color white. So if we start at this letter A, okay, we have this pale orange color here. And then again, the lithosphere would be moving away from each other. So this part would separate into this, and newer lithosphere would be formed in the mid-oceanic ridge, and so on and so forth. So these magnetic polarities are recorded in the lithospheric plates, and this serves as an evidence that the seafloor is indeed moving. Okay, next, we have the age of rocks. We have already discussed this last time, and as we all know, as a piece of lithosphere goes farther from the mid-oceanic ridge, it becomes older. So if we combine the continental drift theory and the seafloor spreading theory together with information on global seismicity, which refers to earthquakes all over the world, then we have the plate tectonics theory, which we discussed in the first few weeks of this quarter. And this theory, the plate tectonics theory, became a coherent theory to explain crustal movements. Okay, so kinoconnect lang natin yung mga diniscuss natin ng una dito sa mga diniscuss natin na bago para malaman natin na related pala silang lahat. Okay, so that's all for now. This is the last part of Earth Science discussion for grade 10. I hope you have learned a lot about the different evidences that support continental drift theory and seafloor spreading theory. And I hope you can use all this knowledge in the next learnings that you will have in the future, especially when you go to grade 11. So again, thank you for watching this video. I hope you like and subscribe if you have learned something from it. So that's it. Bye. Happy learning.